going to be a really quick second half to what we were already talking about. This just gave me an example over here. Okay, the talking needs to stop now. Bryce, move right here, please. Okay. All I want you to do with something that has a base and an exponent is think of it as just x. So if I had 1/2 x equals 1 over 128, you guys would have no problem solving that, right? Seriously, guys. You're telling me you wouldn't know how to solve that? Multiply both sides by 2. I'm doing the same thing here, right? You're trying to isolate the exponential function. This is the exponential part of it. So on this one, right, that's just like saying this is my exponent part, correct? This is my exponential. So that's just like saying x minus 5 equals 1. And you guys know how to solve that. This one, it's the same thing, but this example doesn't apply to it as well. This one, perfect. So this part right here, right, if I turn that into an x, you guys would have no problem solving that either. Do you see what I'm saying? All right, so we're doing order of operations. We're undoing everything. Okay, the next thing that I want to do is, just briefly, is I want to go through and I want to figure out when we're going to use these different formulas. So, Johanna invests $2,500 into an account that earns 5.2 annual interest. How long will it take the account to double in value? Right? So which one of these am I going to use? The one we already know, or one of these new ones? The one we already know. Doug invested $2,000 in an account that he earns 8% annual interest, compounded semi-annually. That's new verbiage, right? Compounded semi-annually means I'm going to use which one of these? Compounded semi-annually. Semi-annually means twice a year, right? So I would use that one for that one. And semi-annually, n would be twice a year, right? So I would substitute in, Captain, put it away, please. I would substitute in a t a 2 right here at the end and here. So I'm just going to set this one up really quickly. Doug invests $2,000 into account. So $2,000 is my initial investment into an account that earns 8%. So I would have 1 plus its earning, right? 8% is 0.08. But that's going to be compounded semi-annually. So that's my 2. So I'm going to divide that by 2. Take into the 2. Take into 2, right? But I need to know that for how many years? We don't know. We don't know how many how long it's going to take, right? So that's the part that we don't know to the t. And we want it to, let's see, he needs $10,000 for a car. How long will it take for the account to reach $10,000? Equals 10,000. We'll talk about it right now. All right, let me move this over here. Okay, you want to know where the n comes from. That's how many times it's going to happen per year. So right here, it says compounded semi-annually. Semi-annually, do you know what semi-annually is? Half the year, so 6 months. Semi-annually is 6 months. Quarterly is 4 times a year, right?
So what are the other terms then?
It's not 2 years, it's twice a year. 2 times a year, semi of the year. Does that make sense? Make sense of it, Essence. Semi-annually means semi through the year, so halfway through the year. So twice a year. Yes.
Does that mean you get 8% twice every year or 4%?
It means, no. Yes, exactly. It's the rate being divided in half,
No, but I'm like,
right?
I know that, but I'm talking about the real world. Is it that you get 8% every month, or do you get 4%?
It's not getting 4. It's getting 4%, and then whatever that is, that's what compounded means. Is that you get that 4%.
So is it 4% now?
No. No, but can we come back to that? Because I have a good graphic for that shows exactly the answer to what you're talking about. Okay? All right. I just want to get people working because they're tired of listening to me talk. Okay, let's look at this one. Stringed instruments like guitars and pianos create a note when a string vibrates back and forth. The distance at the middle of the string moves from the center is called the amplitude, and for guitar, it starts at, that's key right there, right? That's where it starts. That's your A. When a note is first struck, amplitude decays, there's another key word, at a rate that depends on the individual instrument and the note, but a decay rate of about 25% per second is typical. Calculate the time it takes for an amplitude of 0.75 to reach 0.1. So is it one of these or the one you already know? Is there anything talking about compounding at a different rate? Is there anything talking about continuous growth? No, so it's the one we already know. Those are your 2 key words. Compounded continuously and compounded something else. Compounded continuously is E. Compounded something else is that formula. Yes. Okay. The grandparents of a child born in 2016 deposit $5,000 into a fund that earns 4.5, compounded continuously. Which one are we going to use? Continuously. Continuously is E. Okay, let's start. Let's get you guys working. Okay, I want to at least introduce properties of logarithms to you. Okay. Yep. What is a logarithm? Right? It's undoing an exponent, right? It's the inverse of an exponent. Same as undoing, right? So when do we use logarithms? When there's no common bases, right? If there's no common base, we have to undo the exponent, right? We turn it into a logarithm. All right. So here's our power to a power property. That's the one we've been using all along, right? You see that exponent up in where it belongs, in the exponent spot, right? And you pull it out in front. That's what we've been doing. That's what you did on that last worksheet. You did it over and over and over again, right? You isolated, and then you logged both sides, then you brought out in front. So here's our new property. So, let's see. Let me do it like this. So let's say I have x to the 4th times x cubed. What do we normally do with that? That means I have a total of x to the 4 plus 3 or x to the 7th. All right? Let's change it. What if I had 4 to the x times 4 to the y? It would be 4 to the x plus y. All right? You couldn't have done that unless they had a common base. Exactly. So logarithms are exponents, right? So what if I had this? If I have this, right, logarithms are exponents, correct? So I have an exponent and another exponent. So this is called the product property. I can actually split this into two different logs. So what this equals is log of x plus log of y. Okay, so when you see powers, when you see a product, it turns into addition. You guys, please stop. It's a cricket. We'll be okay. Okay, one more property. So here it is here. So if I see a plus sign in between logs, I can put those two logs together, right? Or if I see two logs together, I can separate them by turning them into two different logs. Make sense? Okay, so we were paying attention to the cricket, and now we don't understand what I was just talking about. All right, here's another one. So if I have x cubed over x squared, correct? I subtract them, so I have, it's just like having 3 x's and 2 x's. I can get rid of 2 of them, or I could rewrite it like this. Yes. What do you mean undo them? No. We're not going there right now. We're going right here. We'll go back in a second. Put the phone away. Put the backpack on the ground. Okay. So this is my next rule. So if I have a logarithm that is dividing, what do you think I'm going to turn that into? So just like I did division means I can take the exponents and subtract them, right? So now I have division of logarithms. Now I could turn that into two separate logarithms with subtraction. So if it's divide, it turns into subtraction. If it's multiplication, it turns into addition. Yes? No, it wouldn't be that. Let's just get into it. I think the best way to do it is just to start practicing it. I'm going to do a couple. This. Okay. Yes. Okay, so here's one. Okay, check this out. Now you have to work PEMDAS, right? You have to work in order. GEMDAS, thank you. You have to work in order, and you have to read from left to right. So I can't deal with this subtraction until I deal with this right here. Okay? Why would we complete the square? It has nothing to do with quadratics. Okay, so there's one other thing I see up in there. Here's one property, right? This is the power property. This is the product, and this is the quotient property. Power, product, quotient. I see the product property because I see an addition sign. I see the quotient property because I see a subtraction sign. There's one more in there. Can you see it? There's multiplication. There's the power properties in there. right here. Do you see that? So remember how we used to take the exponents and bring them in front of the log? I'm going to put it back. All right, so let me do this line. So I have log 7, 3 plus log 7y. I'm going to move that 4 right there. Minus log 7. I didn't even see it before. We've got another one here with a 3. Everybody understand that step so far? Instead of the multiplication out front, I've turned it into an exponent. Yes, Kane?
Was the 3 exponent negative?
No. It's saying I'm subtracting 3 of these logs.
So the 3 will
Yes, exactly. It's not a negative. It's saying I'm subtracting 3 of those logs, which is the same as saying these logs to the third power. It means the same thing. Emily? This is part of this, right? You wouldn't see a log like this ever. It always, because 7 to something always, you know what I mean? It has to have something there. Make sense? This is saying I have basically one of these. One of these. I have 4 of these, and I have 3 of these. Okay, so now I'm going to work with this addition sign. Now I'm going to do this right here. So I have, now the important thing about these properties is you can only use them with the same bases. Notice these all have the same base. Okay, so now I have log with a base of 7, and my plus means I'm going to use product, right? So it's going to become 3y to the 4th. I have my 3, I have my y to the 4th, and that's being subtracted by log base 7 x cubed. Hold on, let me just keep going, and then we'll go back to questions. All right, so now I have common bases, and the only thing I have left here is I have a subtraction sign. So now I'm going to use the quotient property. So this is going to be log base 7. I'm going to have a numerator. The one that comes first is your numerator. What is so funny? 3y to the 4th over x cubed. And that's it. It's done. Yes?
Could we have done the quotient property?
Nope.
No.
It wouldn't work. You have to go from left to right.
Why would it? Because without the base.
You wouldn't have got the same answer. You would have gotten y to the 4th times x cubed, and that would end up in the denominator. Does that make sense? Yes.
What happens to the negative?
The negative turned into division, right? So if we see division, we think subtraction. If we see multiplication, we think addition. They just go together, right? Make sense? Yep, just like your exponent rule. When you've got multiplication, you add, right? When you've got division, you subtract. Okay. I think I know what I want to do now. I'm going to give you this, and I want you guys to start working on it. How much time do we have? I think no. Yeah, let's do that. Let's make the homework due on Thursday. I'm going to see you on Wednesday, but we'll take any questions you guys have, and we won't make the homework due until Thursday. Make sense? Both. You're welcome. Get off your phone. Yeah, I'm just pausing my recording.